Okay, this screencast is for Module 1, Lesson 1, which begins in your textbook on page 5. And we're introducing ourselves to solving equations. You've actually done a lot of this before, but it's going to be very important for us to go back, practice, and always brush up on these skills and add new skills as they come along. All right, so first of all, an equation is a mathematical sentence that uses the equal sign. So if it's got an equal sign, you've got an equation. And the equal sign is used to show expressions are equivalent. Okay? So like 3x plus 6 is an expression. But it's not an equation because you need an equal sign. So the expressions can be numbers, variables, constants, or combinations thereof. Okay? You have many ways that you can solve an equation, and one way is by using something called the guess and check. And you just literally guess a number, put it in for the variable, and then work the problem using that number and see if it results in a true statement. If the resulting equation is a true statement, then the value that you've guessed is a solution of the equation. If the equation is not a true statement, then you need to guess again, basically. Okay? Another way to solve an equation is by working backward. In this method, you begin at the end and work backward towards the beginning. So solve the equation x minus 6 is equal to 4, and we're going to use both methods. All right, guess and check, which is not one of my favorite methods. But let's just say we're going to guess 11 for x. Well, is 11 minus 6 4? No, because 11 minus 6 is 5. So those aren't equal. So is 11 the solution? No, it's not. And I would have to guess again to see what the solution is. And that's what I've done over here. So I'm guessing this time 10. 10 minus 6 is 4. Is 4 equal to 4? Yes, it is. So is 10 a solution of x minus 6 equals 4? Yes, it is. Okay? That's guess and check. Down at the bottom, we've got working backwards. X minus 6 equals 4. 4 plus 6 is 10. Is this the value of x before taking away 6? Well, it sure seems like it would be. So you kind of think backwards. Which one do you think is more efficient? Honestly, I think working backwards is more efficient. But really, the most efficient way of doing these is just solving the equation using our identity properties and things like that. So when you see the quizzes later on, it may say guess and check or work backwards or whatever, but as long as you solve for x or whatever missing number you are looking for, I'm good with that. Okay? Okay. A solution of an equation is a value for the variable that makes the equation true. To determine the solution of an equation, you will use the properties of equality. So this is basically how you move things around. For instance, 3 is equal to 3. We know that. If we add the same thing to both sides, then they're still equivalent. Because A is equal to B, if I add C to the left side, but I also add C to the right side, I still have an equivalent equation. Okay? Subtraction property of equality, if I subtract the same thing from both sides, I still have an equivalent equation. If I multiply both sides by the same thing, I still have an equivalent equation. And finally, if I divide both sides by the same thing, I still have an equivalent equation. So just keep those 4 things in mind. I think I've said this before, but basically the bottom line is when you're solving an equation, you have 2 basic rules. Number 1 is that if you are going to move something to the opposite side of the equal sign, you do that by using the opposite operation. So if it said plus 7 and you need to move the 7, then you're going to do the opposite, which is minus 7. So you do the opposite to move, but the other rule is that whatever you do to one side of the equation, you have to do the same thing to the other side. So just keep those in mind. Okay, and now we get kind of down to business, solving using the properties of equality, basically meaning whatever I do to one side, I do to the other. So I have 3x minus 2 is equal to 6. It says use the addition property of equality. So minus 2, I'm going to do the opposite to move it. I'm more used to doing this where I show it underneath. So, for instance, I've always been accustomed to doing this. Okay, plus 2 to this side, plus 2 to this side. And then after one step, I have 3x over here, because those cancel. And I have 8 on the right-hand side. But that's exactly what they're doing here. It's just they're doing it in a line, and I'm doing it one underneath. Then to solve for x, you would divide both sides by 3. So as long as you're dividing both sides by the same thing, you're good. And x is equal to 8 over 3. All right, on the next one, you have 1/2 z plus 4 is equal to 10. The first thing that they recommend that you do is subtract the 4. Okay? Again, I prefer this way, but it's totally a matter of preference. I prefer doing it like this just because I can keep track of things better. Okay? Okay, so those cancel. 10 minus 4 is 6. And then I've already combined the like terms, so that's 6. And then I'm going to do the opposite, because remember, whatever I want to move, I have to do the opposite. So if I have 1/2, if I multiply that by 2, then that gets rid of, it's a 2 on top, 2 on bottom, that gets rid of it. So I'm going to multiply both sides by 2. Okay? So multiply by 2, by 2. And I get, oops, that's supposed to be 6. And I get 12. Okay. Okay, so once again, your big rules are do the opposite to move something to the other side of the equals, and whatever you do to one side, you have to do the same thing to the other. All right, let's go on to page 7. All right, what's the goal when solving a one-variable equation? Well, you want to solve to figure out what number makes the equation true. And we've got more practice down here. We're going to say plus 10 on this side, plus 10 on the other side. Over here, that's going to cancel it out, and I get 5x equals, and then 20 plus 10 is 30. And then my next step is to divide both sides by 5. And I get that x equals 6. I can make sure that it's accurate if I will go up here. 5 times 6 is 30, minus 10 is 20. That checks out. All right, up here. First thing I think I'm going to do is subtract 9. Minus 9 on both sides. 21 minus 9 is 12, I think, last time I checked. I have 1/3 x equals 12. Okay, so I have 1 over 3. 1 divided by 3, so multiply both sides by 3. So now over here, I just have 1x, so I'm just going to call that x. And then 12 times 3 is 36. Okay, and again, how do I make sure that I've done the problem right? Well, I'm going to take 36 and I'm going to put it back in here for x. 1/3 of 36 is 12, and 12 plus 9 is 21. So that's true, it checks out.